Okay, this video we're going to cover 2010 free response questions number 1 through 3. Okay, question 1 is your experimental design question, kind of mixed in with some linear regression in part B. Okay, part A, we want to, for the experiment, identify treatments, experimental units, which means subjects, and the response that will be measured. So grading this question. Okay, scoring, part A. I need a couple parts, 3 parts. You correctly identify all 3 subparts. 2 of the 3 is a P, I otherwise. So my treatments are going to be the 5 different concentrations of garlic in the food. The experimental units are the birds, and the response is the number of food granules consumed by the bird. Okay, so part 1, garlic oil infused into the foods at the 5 levels. These represent the 5 treatment groups. Done that. Subjects, or the experimental units, are the 40 birds. I have them. And the response being measured is the number of food granules consumed. That can be a little bit tricky, but I'm trying to determine the adverse reaction of the birds to the repellent by measuring the number of food granules consumed during a 2-hour period. That's in the context of the question. Okay, so I've done those 3 things. That's going to earn me essentially correct. For part B, you just need to think about what you have here. I mean, this is a huge, huge hint. Linear regression. This is a linear regression. So the only kind of graphs we talk about with linear regression are scatter plots and residual plots. Okay, so in this case, I'm going to use a scatter plot to investigate the appropriateness. All right, scoring for this question. It's essentially correct if you produce a correct graph, a reasonable scatter plot or residual plot with correct labels and scales. Okay? This is really, really, really important. Okay? Any of these are going to be incorrect. Incorrect scale, reversed axes, missing labels, other types of graphs. Incorrect scale. This is where they're trying to trip you up, something very simple. Okay? They didn't give you nice intervals of 10. They give you 0, 2%, 10%, 25, and 50. So the highest is fixed 50. I'm going up by 10s here. This has to be consistent. Because these are attached, I have to start them both at 0. The highest number of granules consumed was 58. So you can go up by 10, something like that. I went up by 6s, so every other one was 12 to get up to 60. Labels, mean number of granules consumed, garlic concentration in percent. Just graphing these. We're not fitting a line to this. We're just putting the dots. It's a scatter plot. I have no linear regression. I'm not drawing a curve between these two, so I've done that correctly. Part 2, based on your graph, do you think the linear regression model is appropriate? What I'm looking for in scatter plots are 3 things. Quantitative data, check. No outliers, and the straight enough condition. Well, the straight enough condition is absolutely not satisfied in any way, shape, or form. So, no, the scatter plot does not show a straight pattern. It is curved. As a result, the model is not appropriate. So the second part is talking about the pattern does not appear to be linear. It's curved. So I've done both of those things. That's going to earn me essentially correct. With 2 parts in the question, E's are worth 2 points, P's are worth 1 point. I have 2 E's. This is going to give me a 4 on this question. Okay, question number 2. This question deals with sampling distributions. It deals with a little bit of inference in terms of sampling distribution. It also deals with a little bit of using z-scores here. So let's take a look at that question next. Okay, in part A, looking for the scoring for part A, E, P, or I, it's essentially correct. I'm describing a distribution, so I need to think about cos. All 3 components, shape, approximately normal, center is going to be that mean that they gave you, and the spread. Well, I have a sample size of 40 now, so it's going to be 0.174. Center, shape, and spread. There's no unusual features to talk about here. So you'll notice here, I just defined a random variable, the mean song length of one rock and roll song. So the expected value is 3.9. Standard deviation is going to be 1.1 over the square root of 40, 0.174 minutes. Minutes, this is quantitative data. Describing this, the distribution is centered at 3.9 minutes with a standard deviation of 0.174 minutes. The shape is roughly symmetric because the population distribution is stated so. Therefore, the sampling distribution is approximately normal with the parameter 3.9 and 0.174 for the mean and standard deviation, respectively. Okay, they told you in the context of the question here, it's the length of rock and roll songs is roughly symmetric. So that's why the normal model is going to apply here. Okay, so I've done those three things. I have those three components in part A. That's going to be essentially correct. Taking a look at part B, it's essentially correct if they set up and perform a correct normal probability calculation. It's partially correct if you set it up but doesn't carry it through, or you set up something incorrect but you carry it through correctly. Part B, there's a couple different ways you can do it, as seen in the rubric. I like this way a little bit more than my way, actually a lot more than the way I chose to do it. You have 160 minutes, 40 songs, so if I divide, the average needs to be 4. That's my statistic. I have a mean of 3.9 from part A and a standard deviation of 0.174. Get a z-score, calculate the probability. That, in my mind, is easier than the way that I chose to do it. Okay, an alternative way you can do it, as you'll see on my paper here, is wherever the question may be. Let me try to find that. 2A, 2B. Here we go. Okay. So I have 40 songs. Each time length is independent, so I have the expected value of those 40 songs is the 3.9. The average times the 40. I could do 3.9 plus 3.9, 40 times 156 minutes. Standard deviation, same thing. I have independent random variables. Their variances always add. So the variance for each one is 1.1 squared plus 1.1 squared 40 times. Standard deviation is 6.96 minutes. So I have a normal model. That's my mean. That's my standard deviation. Calculate a z-score. Do some norm CDF from that to 999. I'm going to get about 28%. Okay. This is going to earn me essentially correct. I did it an alternative way, but that's listed in there. That's still essentially correct. 2 parts here. E's are worth 2 points apiece. P's are worth 1 point apiece. I have an E and an E. That's worth 4 points. So questions 1 through 5. Each point you earn is worth 1.875 composite points. On average, you need to have high 30s, low to mid 40s to earn a 3 on your exam for composite. Okay, question number 3. Taking a look at this one, here's some inference going on. I have a confidence interval that I see. All right, so that's going to be part of this question at least. Okay, scoring A, B, and C, E, P, or I. So for part A, it's essentially correct if you have a correct interpretation, and you could take one of 2 approaches. So based on the concept, you must fulfill the following 3 requirements. Mentions repeated sampling in the long run or using this method. Mentions that 95% of the intervals will capture the population proportion and includes context. The second way that you can do it is based on probability. They must state there's a 95.95 probability that a random sample selected in the future. Okay, I didn't teach that method. You should be here. You should be looking at this number 1 on your scoring guideline. So what I'm fearful of is many of you wrote, we are 95% confident, blah, 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 and just did that. We're interpreting the confidence interval. I'm sorry, we're not interpreting the confidence interval, we're interpreting the confidence level. Huge, huge, huge concept, but tiny difference. This is chapter 19 where this was introduced. So, in many random samples of the same size, about 95% will produce confidence intervals that contain the true proportion of households in the country that own at least 1 dog. So, mentions repeated sampling. Did that. And many random samples of the same size. Mentions 95% will capture that. Did that. Includes context. Did that. I've done those 3 things. That's going to earn me an E for part A. For part B, it's essentially correct if you state that because 0.39 is in the interval does not provide evidence that the proportion of dog owners in the county is different. Partially correct if you indicate the goal is to check whether 0.39 is in there, but have some issues with that. Or you correctly note that it's in there, and then you conclude that 0.39 is the population proportion. All right, so let's take a look at what you need to do here. you'll notice I set up a null and alternative. The claim is it's 0.39. It says, does it differ? Is it different? So the alternative is p is not equal to 0.39. So I took my sample statistic plus or minus my margin of error, just did that by hand to get 0.298 to 0.536. There's your confidence interval. So answering the question, does it differ? No, because 39% falls within the 95% confidence interval. You have to include this. I can't just say the confidence interval. I would fail to reject the null. Okay? There is weak evidence that the proportion of households in this county is different than 39%. You know what? I'm not a fan of whatever. I need to say more. I need to put more context in this. There's weak evidence that and I should have used some of my own advice, that the proportion of dog owners in this county. So I don't really have good context here, so I'm going to give myself a P. Okay, there's 2 parts done. Let's look at part C. Okay, part C, we haven't seen a question like this in a while, but it's definitely something that comes up pretty much on every AP exam, if not on multiple choice on free response. How many households were selected in the Humane Society sample? I believe this is chapter 19 as well when we first looked at this. Show how you obtained your answer. So what I need to do is I need to take my margin of error, 0.119, is equal to my critical value times my standard error. Be very careful here. You know what this is p hat. I'm not going to use that 39% because that was just a claim. It was said we're selected in the Humane Society sample, so I'm using the sample p value, p hat. And then I'm just solving this out. I get 65.95 and so on. You're always rounding up to the next integer. So they use 66 as their sample size. So scoring provides a correct equation with correct values substituted in a correct integer solution. I have that. Partially correct. If you use 0.5 or 0.39 instead, common mistake, you have a non-integer answer. Common mistake. You don't. Those are the 2 most common mistakes. Okay, if you're making 2 of these mistakes, it's an I. It's immediately going to be an I. Okay, I've done those 3 things. That's going to be an E. Okay, as far as scoring goes, this question has 3 parts, so it's going to be a little bit different than what we've seen. All 3 parts correct. That was what I hoped for, but I didn't get. I had 2 parts essentially correct and 1 part partially correct. That would be a 3. Remember, your goal on question 1 through 5 is a 2 or higher. So a 2 is going to earn you about 3.75 point composite points. Okay, so again, you want to be in the high 30s, low to mid 40s. That's usually where the cutoff. Actually, it's usually in the low to mid 40s. I should stop saying 30s. It's usually between 40 and 45 where it starts to transition into earning a 3. Okay, so next video I'll cover 2010 number 4 through 6.